back, guys. So today we will be learning about assumed mean. Okay, so first of all we will have to understand a basic characteristic of a mean. I will explain by an example. Okay, so let's say we have data 1 2 5. Okay, what is the mean of this data? Let's just do it 3. Let's just do it 3 for better results, like for simpler results. So for mean we just add all the values. So 1 plus 3 4 plus 5 9, and we will do 9 divided by 3. Let me just write it over here. 9 divided by 3, which would be 3. So the mean would be 3. Okay, what if I add 3 to all these values? Let me just okay, so what if I add 3 to all these values? What will then happen? We will have 4 7 and 5 plus 3 8. Now what would be the mean? The mean would be 4 plus 7 plus 8 19 over 3. Sorry, this is not 7, this is 6. So it would be 18 over 3, and that would be 6. Okay, so if we see the difference between means, that has also been added by 3. You see, we have added 3 to all values and the mean also got added by 3. Similarly, if we look at another example, let me this time multiply this 1. Oh, I'm so sorry. Okay, let me this time multiply this 1 with 3. Just take 3 again, and now we will have 3 times 3 9, 5 times 3 15. Okay, so the mean here would be 3 plus 9 12 plus 15, and it would be 27. Okay, 27 over 3, that would be 9. Okay, so the initial mean was 3. Okay, and now we have 9. This is basically multiplied by 3. Okay, so as we can see, if we multiply all the values, if we multiply all these values with 3, the mean also gets multiplied by 3. Okay, so this is a basic principle or characteristic of a mean. If we add, subtract, multiply or divide all these values, all the data, the mean would be affected in the same way. Okay, so let me now consider an example. Okay, so what if we have a data? Let me just write some data over here. Now we're moving on to a question. Okay, our data we have is, let's say 15 25 35 45. Okay, now for simplification reasons, if in exam conditions you have to add 15 25 35 45 on your calculators or manually, that is more prone to errors, right? So what if we simply assume, we write a is equal to minus 15. Okay, which means that we are subtracting 15 from all these values. So it would be 0. 25 minus 15 would be 10. 35 minus 15 would be 20, and 45 minus 15 would be 30. Okay, so now it's more simpler. First, if we had to manually add all those values, the initial values, now it's simpler that we can only add these more easily, like 10 plus 20 plus 30, it's simply 60, right? So and now let's just assume, let me just give these values, like this is x and this is y. Okay, so the mean of y would be 60 over 4, which would be 15. The mean of y would be 15. Okay, we don't know the mean of x, right? We need to calculate the mean of x now. So we although we can do it simply by adding all these values, but I just told that in exam conditions, let's say you have values like 5.5 6.25 9.85, all these decimal places, then it gets complicated. So the advantage with assuming mean is that now you can calculate the mean of x with ease. So basically the mean of x is equal to the mean of y plus 15, or you can put it differently, that the mean of x, when we subtract 15, like this 15, if we subtract 15, then it would be the mean of y. Okay, so we have the mean of y, which is 15, is equal to minus 15 x mean. Okay, the mean of x would be 15 plus 15 is equal to 30. Okay, you can counter check over here. This is just for simplicity reasons, but in a real question you won't have these values. You would only have this assumed mean and this data, and so you can't counter check by calculating the mean of x. But here, for understanding purposes, we can counter check by calculating the mean of x. Okay, so to calculate the mean of x, we will do 15 plus 25 plus 35 plus 45 over 4, and that would be x naught, x dash, or mean of x, and that would be 15 plus 25 plus 35 plus 45 over 4, and that is 30 again. Okay, so here we can see the match. Okay, so that is what is assumed mean.